Today, let's go over a medium question in the design category that I just solved by myself a couple minutes ago. I got time limit exceeded, but I finally got it to work, so let's go over it. The question itself is pretty simple. It asks you to design a number container system that inserts or replaces a number at a given index in a system and returns the smallest index for a given number in the system. And you have 3 APIs here you need to implement. So pretty simple, right? Map the key to the value and then return the smallest key that has that value. And then -1 if there's no value that maps to that key anymore. So the naive way to do this is to use a dictionary, right? And then just use the index as the key and the number as the value. And we're just going to print this out so you can see. Okay, so actually let's also print the actual number we want. So the number is 10 that we're looking for. Which key is 10 is the smallest? It's going to be 1 here. There's no value in the dictionary with 10, so we're going to return nothing, or -1 here. Here, the smallest value with 10 has shifted. It's not 1 anymore, it's 2 because 1 has been replaced by 20. So that's a little confusing. And let's try to come up with a naive solution first. So then we can just say for k in self.d, if self.dk is equal to number, then we can keep track of the minimum, right? So let's declare this to infinity because nothing is bigger than infinity. So minimum of result in k, which is the current key we're looking for. And then at the end, if result hasn't changed, if it stays as float infinity, return -1, otherwise return result. So pretty simple, just looking for the smallest key that has that value. And it works, but it gets time limit exceeded. So as you can see, okay, so instead what we want to do is come up with another solution where instead of doing this, let's keep track of let's have 2 dictionaries, right? Let's map the index to the value and the value back to the index and find the smallest one. So let's call this SD, and let's create a default dict of let's say sorted list, because what we want to do is actually get the minimum, and that costs time complexity again. So okay, so now let's try to think about this. We want one dictionary to have this, and then we also want another dictionary to have, let's say 10 maps to 2, 1, 3, 5. But then when 20 comes in later on as another value, we want to remove it from 10 and say the smallest index is 2, right, instead of 1. So, okay, this is a dictionary. And so we have to find values that we've already seen before, right? So let's call this self.scene and make a set. And we're just always going to add the current index that we've already seen, right? We've already seen 1 in another has been inserted into another list in the value section, so we're going to mark it. And if it is, then first of all we have to remove it from 10, and that's the hard part, right? So first of all, let's try to come up with another solution. So let's say if if index in self.sd number, because number is 10, right? Let's call this default dict. I don't want any errors here. List, because we're going to be appending. This is a list, right? If it's inside of it, then self.sd number dot remove index to get rid of the 1. Okay. After we got rid of the 1, then we're good. So we still have to say self.sd number. Okay. self.append index. Let's pass this. Let's print self.d, self.number, and then self.sd. Okay, so, all right, this is not correct because it still has 1 in it. We want to remove 1. Okay, so self.sd number. Okay, we're going to use the scene now. So if the current index is in self.scene, and if the number, or if index in self.sd number, then let's do this. It's still not removing. Okay. So okay, self.scene, self.sd. If it's in scene, yeah, then we have to find the corresponding key value pair. Okay, which is going to be confusing because now we have to say that the key value pair before that, before we update our dictionary to 20, so the value we want is going to be self.d index, and then self.sd of this value dot remove the index. Okay, cool. So now if our number that we're looking for, if number in self.sd, then self.sd.remove, or return minimum of self.sd number, because we're checking the keys, else return -1. So again, that works, but this is still O of n. This is still O of n. Okay, if self.sd number, if it has elements in it, then we can do that. Otherwise, return -1. So almost works. Except it doesn't. So again, let's come up with an even better solution. Okay, so remove is O of n. So how about let's try a sorted list instead of a list, because that keeps the order. So we don't have to do the minimum here, right? Okay. Okay, dot remove, dot add instead. So we want to return self.sd number 0 because that's going to be the smallest one, right? So there you go. And that passes all test cases because sorted list basically just keeps everything in sorted order. So as you insert and delete, you're just going to have 1, 2, 3, 5, and you're just going to pop 1. You're just going to get the 0th one. So it's very, very efficient. Get rid of this pass, but as you can see, that's what it takes to pass. So really powerful, the sorted list. So I hope this video was helpful, and please consider subscribing and stay tuned for more content.